Hi everyone. In this part, we're going to be looking at atom economy. Let's consider a particular reaction between carbon monoxide and water to produce carbon dioxide and hydrogen. So let's say that in this reaction, our aim is to get hydrogen. Now, in order to make hydrogen, using this reaction, we're going to be using carbon monoxide and water. So these are the reagents. So the atom economy is going to be a measure of the amount of starting material or raw material that is being converted to useful products. Atom economy is given as a percentage. The lower this percentage, the more waste you're producing, and the higher the percentage, the less waste you have and the more useful products you have. So let's find the atom economy for hydrogen in this reaction. So the first step is to write a balanced chemical equation. So we have our chemical equation. We're just going to verify if it is balanced. So this is good. The next step is we're going to find the MR of all the reagents that are used. So we're going to use the periodic table, find the AR of carbon, find the AR of oxygen, and we add them to get the MR of carbon dioxide. And then we're going to find the MR of water. So 2 times AR of hydrogen plus 1 times AR of oxygen. Right. So we're going to find the total MR of reagents. So this gives us 46. And then we're going to find the MR of the useful products. So if you have more than one useful product, you're going to add them up. But in this case, and usually we're going to have one useful product. So in this case, it's 2 times 1, so that's just 2. So then you have the MR of useful products. So the percentage atom economy is going to be the MR of the useful product divided by the MR of all the reagents times 100. So this is 4.3%. Now, as you can see, this one is a very low percentage, which means that we have a lot of wastage that is happening. So this reaction is not an effective way to produce hydrogen because we have lots of waste. Now, atom economy is very important to be considered. Firstly, because raw materials are expensive, and the more you waste them, the less profitable it is. So in this case, we have lots of the reagent that is being converted to carbon dioxide, which is actually going to waste. The second thing is that you're getting very tiny amounts of products, so it's less sustainable, and you're getting a large amount of waste, and waste products are usually expensive to dispose. Either it's going to accumulate or you're going to try to burn them, and when you're burning them, you're going to affect the environment. So it's very important to consider the atom economy. Now, if you have a reaction where the atom economy is low, there's 2 possible solutions. First is either to find a more efficient reaction where the atom economy is going to be higher, or you find a use for the waste products. So instead of disposing that waste product, you could sell it or find a useful substance that can be made from those products, from those waste products. Now let's try another example where you have the stoichiometric ratio being involved. So in this reaction, you need to find the atom economy of iron. We have the equation that is given to us, and when we look at it, we see that it's not balanced. So we'll balance the equation first here, and then we're going to find the MR of the reagents. Now, we are going to take into consideration the stoichiometric ratios. So here we have 2 Fe, we have free oxygen plus free oxygen, so 6 oxygen, and then we have free carbon. So make use of the periodic table for the AR values. So you add everything up. So this is the AR of the reagents. You have to be very careful. Make sure that you include the stoichiometric ratios in the calculations, and that you're going to use your calculator over here. Now, because we're finding atom economy for iron, now we're going to find the MR due to the iron. So here you have 2 times Fe. So you're going to have 2 times Fe here. So here we have the answer. Therefore, the percentage atom economy is going to be the MR of the product divided by the MR of the reagents times 100. So as you compute it, you're going to get 45.8%. I'm giving my answer to 1 decimal place. Now, a percentage atom economy of 100% means that there is no waste that is being produced and that all the products are useful products. Now, you have these 2 questions. You're going to find the atom economy of CH2Br2 here, which is dibromoethene, and then you're going to find the atom economy of hydrazine, N2H4.